In this lecture, we are going to take a look at a concrete example for garbage collection. So I'm going to create a new class, for example, car, and the car class is going to contain a so-called finalize method. This finalize method, as you can see, is called by the garbage collector on an object when a garbage collection determines that there are no more references to the object. So this is what we have been talking about in a previous lecture when we have been talking about a theoretical background for garbage collection. That garbage collection algorithm is going to check whether are there any active references for that car object. And if there are no active references, then it's going to get rid of that object, and before removing that given object from the heap memory, it's going to call the finalize method. Okay, so this is the protected void finalize that throws throwable, and here we are going to print out, just for demonstration purposes, we print out the object itself, object cleaned from heap memory. Okay, so this is what's going to be printed out whenever the garbage collector removes that given object from the heap memory. And in the application, let's check if we create a new car. This is what we have been talking about as well, that this is how we instantiate a new object, and this is the reference to the given object. So this reference is in the stack memory, the object is in the heap memory, and we are able to access the object with the help of the reference. Okay, so let's try to set the car reference to be a null. What's going to happen? In this case, there is no longer an active reference to the object, which means that this car object is eligible for garbage collection. So we can call system.garbage collection with the help of this GC method, but this is what we have been talking about in a theoretical section, that garbage collection is rather non-deterministic. So because there is just a single object, it doesn't have any active references because we set it to be a null, and we call garbage collection, but despite the fact that we call garbage collection, usually nothing happens. If you run multiple times, then sometimes Java virtual machine is going to call garbage collector and it's going to run the finalize method in the car class, but there are cases when there's nothing happen, as you can see, like in this case. So this is why I told you that garbage collection is rather non-deterministic. As a software engineer, we are not able to control garbage collection. So sometimes it is working fine and sometimes it is not. So for example, if we use a for loop and I is smaller than 50, I++, and we create several car objects, then we set the references to be a null, and then we call system.garbage collection. Again, sometimes it is going to work fine, but sometimes it's not going to work because there are going to be just 50 car objects on the heap memory, which is not a huge number. So this is why Java virtual machine may come to the conclusion that okay, there are enough free memory in the heap, and this is why Java virtual machine is not going to run garbage collection despite the fact that we call system.gc. So if we run it, okay, then the garbage collector is going to be called, but as you can see, it should be called 50 times. And here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is called 20 times and not 50 times. So again, we can come to the conclusion that the garbage collection mechanism is rather non-deterministic. Despite the fact that we call garbage collection explicitly, sometimes garbage collection is going to run, but sometimes it's not going to run. So finally, let's consider the situation when we create 5 million car objects, but without the system.gc. So in this case, we are not going to do something like this. So we are not going to call the garbage collection procedure explicitly. And if we save it and run it, then as you can see, Java virtual machine is going to call the garbage collection automatically, because if the Java virtual machine calls garbage collection, then garbage collector is going to run the finalize method of the given class automatically. So this is why we know that the garbage collection has run. You may pose the question that what is the conclusion? First of all, the conclusion is that garbage collection is rather non-deterministic. The Java virtual machine is going to decide whether to run garbage collection or not. If there are just a small amount of objects in the heap memory, then usually Java virtual machine is not going to run garbage collection. So basically there's no need to call system.gc because the Java virtual machine is not going to run garbage collection anyways. But if there are a huge amount of objects on the heap memory, then we don't have to call system.garbage collection because the Java virtual machine is going to run garbage collection anyways because of the huge amount of objects in the heap memory. And this is why system.gc is a bad practice, because let's recognize that system.gc isn't an absolute solution and we are not able to rely on this solution as a software engineer. What's crucial that instead of calling system.gc, maybe we should refactor our implementation. We should make sure that we hold active references to objects that we need in the future, and we have to make sure to get rid of the references and set them to be a null if we do not need that given object anymore. Because if there are no active references to given objects, it means that these objects are eligible for garbage collection. So that's all about system.gc and garbage collection. Thanks for watching.